Today we are going to continue with our properties of exponents, and we're going to add 3 new properties to the list. One new property that we are going to add is what we do with a negative exponent. Now the key to understand here is that we never write an answer with a negative exponent. It is not simplified. So while we can get negative exponents inside of a problem, we would never leave that as our final answer. We need to simplify it. And a negative exponent tells us that it is on the wrong side of the fraction. So if it's in the numerator, it needs to go to the denominator. And if it's in the denominator, it needs to go to the numerator. So for example, if I have x to the negative 5, I am moving my base with its exponent to the other side of the fraction. So since I didn't see a fraction, that means it's in the numerator in the top. So I'm going to move it to the denominator, which is the bottom. Now I can't leave one side of a fraction empty, so I'm going to fill that in with a 1. However, if I look at my next one, right, I have w to the negative 2. The only thing that is moving is my exponent and my base. I do not move anything else. So that 4 is staying put in the numerator, and it is the w that is moving, right? Once I'm moving this, that negative comes off. I have moved it to the appropriate location, and I no longer write that negative down. So if I look at example 3, the 8 and 3 are staying where they are because they don't have a negative exponent. It's the b that has a negative exponent, and it needs to be moved up to the top. So the 8 is staying put, the 3 is staying put, the b to the first is moving to the top of the fraction, and once it's there, that negative is coming off. So example 4, this a to the negative 5th needs to move to the other side of the fraction, so it's going to move down. But my c to the negative 6 needs to move up, and when it moves up, it becomes a positive. So I end up with a c to the 6th over a to the 5th. Now we really use this property inside division, because when we divide with exponents, we subtract the exponents. Okay, and what is really happening is when I have x to the 7th, that's going to be 7x's, over x to the 5th, which is 5x's. But the key is that anything over itself is 1, right? 4 divided by 4 is 1. 7 divided by 7 is 1. So x divided by x is 1, and those cancel out. So all of these x's over themselves will cancel out, and I'll just be left with x squared. Right? Well, instead of writing that out every single time, what we can do is we can subtract the exponents. So 7 minus 5 gives me 2. Okay, the problem, for example, is example number 2. When I take 2 minus 9, I get negative 7, and I cannot have a negative exponent in a problem, and so I move that c to the 7th to the denominator. Now, you don't have to write this down as a second step, right, as an additional step. You can just say 2 minus 9 is negative 7. A negative goes on the bottom of the fraction, which is totally fine. Now, what we have to remember is that the coefficients in front function like a normal fraction. So we need to reduce the fraction 12 over 18. 12 and 18 are both divisible by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. Okay, now I can only subtract the exponents on things that have a matching base. So I'm going to look at my a's. Those have a matching base. So I'm going to take 5 minus 3. 5 minus 3 is positive 2, so I'm going to write that in the numerator of my fraction. Then I'm going to look at my b's. I don't see it, but there's really a 1 there. 1 minus 7 is negative 6. That's negative, so it's going on the bottom of the fraction. Now, I'm not writing the negative down. The negative just told me a location, right? The location is the bottom of the fraction. Okay, if I look at example 4, 5 over 20. Again, I need to simplify 5 over 20. It's not 20 divided by 5. It is 5 divided by 20. So this is going to be 1 over 4. And then I'm going to subtract my exponents. Now be really careful here. I need to take negative 2 minus 2. And negative 2 minus 2 is negative 4. So I'll have y to the 4th on the bottom of my fraction. The last property that we are going to look at is an exponent of 0. And our rule says that anything to the 0 power is 0. Now there is an exclusion for 0 to the 0 power, but we're just not going to deal with that one. Okay, so this says x to the 0 power is 1. Really, it doesn't matter how big or small the number is. If it is receiving the exponent of 0, it becomes 1. So negative 23 to the 0 power is 1. 22, a to the 15th, all over 7w to the 11th, all to the 0 power is 1. Now, where we have to be careful is when we're looking at problems like this. Just because we see an exponent of 0 doesn't mean it is all receiving the exponent of 0. So in this problem right here, this says 8 times y to the 0 power. That 8 is not receiving the exponent of 0. So y to the 0 power becomes 1, but then I'm left with 8 times 1, which is 8. Whereas on my second one, right, this says everything is receiving the power of 0, and so that is equal to 1.